my name is Dr. Chris Zimmermann and I'm an open source fanatic and have been part of this community for more than 30 years. Working at Redis Labs, the home of Redis, I'm looking after Germany, Austria and Switzerland, both from a pre-sales and community management perspective. Today, I'm going to talk about a pretty versatile chameleon called Redis. One of the main features of this in-memory NoSQL database is the ability to extend it with something called modules, essentially turning native Redis into an application-specific database, which is able to store your graphs, documents, and time series, etc. My name is Chris Zimmermann, and this is my presentation on Redis, a multi-model database for the Internet of Things and beyond. First of all, very good morning to the audience. So what this is all about, let me give you a short overview, short introduction, of course. Then I'm going to talk about an in-memory NoSQL database called Redis. Probably some of you know it already. It's quite popular, but more on this later. I'm going to shed some light on use cases in this area, and then, of course, it's a short wrap-up section, and then it's questions and answers, as usual with these presentations. Needless to say, I would really like to have given this in front of you in person, but unfortunately, due to circumstances beyond my control, it has to be online. And of course, as you may know, there is a Ask Me Anything section after the presentation. So feel free to join this Zoom conference to ask any questions you may have, not necessarily on just the IoT use case, but also Redis in general and its ecosystem. But first of all, a little bit about me, who I am and what I do and where I come from. It all started about 30 years ago. That was my kind of first crush with open source technology. I'm a techie through and through. I did my PhD in reflective operating system architectures, something that found a lot of echo afterwards in things like the Java Reflection SDK as part of the Java 1.5 SDK. During my PhD, I came across something called Linux. We used this free and open source operating system back in the early 90s to develop our experimental microkernel architecture. That was part of the PhD thesis. And I've been using Linux ever since. And I started with kernel version 0.95, so very early days. FOSS and its ecosystem as in free and libre open source software plays a very big role in my life. For example, I'm chairing one of the largest Linux user groups in Germany called the Frankfurt Look, and there I am on the board for tech support, making tea a little bit more. I'm also an Arch package maintainer. For those of you who know this Linux distribution, I maintain two packages there. And other hobbies include being a community liaison and a solution architect at Redis Labs, the home of Redis. Anything that has to do with a software development lifecycle, right from quality right up to testing and so forth, but also, needless to say, coding itself and stuff. And a hobby that came into my life about 10 years ago is IT security and other forms of black art. And if there's still time left, I run a podcast called Linux In-Laws. You check it out. A friend of mine and myself started this about almost a year ago. It's a podcast on, needless to say, free and open source software with a little bit of humor thrown in. Feel free to check it out. First of all, let's shed some light on what Redis is. Redis is 10 years old. The first commit was actually in 2010, 21st of March, if I'm not completely mistaken, done by a guy called Salvatore Sanfilippo, who at the time had the requirement of looking out for technology in the area of fast databases for a web reporting project that he had to do. He checked out Postgres, he checked out MySQL, he also checked out Memcache. None of these technologies were meeting his requirements, so he sat down and wrote something what was then a simple key value store. Hence the name Remote Dictionary Server, Redis. The idea, in contrast to, say, MySQL or Postgres at the time, was to focus on the storage of data and the processing of data, not on disk, but rather in memory. So any value, any key that is attached to this value or vice versa in Redis is stored in memory. Needless to say, Redis does support persistence, but this is not the primary focus of Redis. So this is basically what you see when you take a look at the use cases where Redis is used. Caching is something that naturally came very short after Redis came into existence. This is also the main use case where people still use it for. Website caching, session caching, anything where high performance and low latency play major roles. But over the years, Redis has become much more. Let's take a look. But first of all, some numbers, of course. The Redis community, short overview slide. Redis is probably the database, the NoSQL database with the largest client ecosystem. There are more than 170 clients for over 50 programming languages available. The standard languages like Python, like C#, like C++, like Java have typically more than one client at implementation with different levels of richness, with different level of functionality. So this is the true spirit of open source. You can pick and choose depending on your particular requirements. The number of GitHub commits is almost reaching now 10,000 these days. So 1,000 commits roughly per year, which is, I wouldn't say quite a lot, but it's not too modest either on average. And of course, building on this ecosystem, we have more than 100 higher level libraries and tools. I'm going to shed more light on this later. The project itself has more than 46,000 GitHub stars. For those of you who don't know, GitHub stars is the currency on GitHub that expresses the popularity of the code base. So this is something I think the contributors and the community working on this can be somewhat proud of. And of course, speaking of which, there are more than 500 contributors. I'm actually one of them. The last major thing that I did was to extend the Python standard client, which is called Redis Py, funny enough, with streams functionality in 2018. Eventually, the pull request was merged into the overall code base and maintained by Anime Curvy, who's the maintainer on GitHub of Redis Py. And since December 2018, yes, you can use streams from your Python client-side implementation. And of course, there's also a vibrant community on Stack Overflow, but also on Discord. Moving on. What is Redis? Redis is a database. That's quite clear. It's a NoSQL database. So it doesn't have, in contrast to SQL-based databases, what's the word I'm looking for? Schema definitions, tables, rigidness, let's put it this way. But it does support a significant number of data structures. This is what you see on the left-hand side of the slide. Strings is where it all started with. These are binary safe strings. The strings can be up to 1200 megabyte in size, meaning you can put anything into strings as long as you observe the size limit. I've seen MP3s being put into strings. I've seen MP4s being put into strings. So anything goes because they are binary safe. Other data sets include bitmaps and bitfields, allowing for the compact storage and processing of bit-like data structures. Hashes is essentially a collection of strings associated with one key. Lists, as you know them from programming languages, are just arrays of values associated with the key. In Redis, there are two types of sets: ordinary sets that you know from Math 101 or Algebra 101, and something called sorted sets. The main difference between a set and a sorted set is actually that each and every item in a sorted set has a score attached to it, meaning you get a sorting order or a sequence, let's put it this way, right out of the box depending on the score. So the implementation of, say, for example, leaderboards or recommendation lists that you would typically find in your e-commerce solution is quite straightforward, because based on the popularity of an item, you simply attach a score to it, and Redis takes care of the proper ordering of these items in that set. Other data types include streams. Stream is somewhat comparable to something called Kafka, i.e. a scalable message bus-like structure that allows you to attach more than one consumer to a pipe. In contrast to Kafka, of course, streams are processed in memory, giving it a very fast performance and low latency. We're going to come back to streams in a minute when I go into the IoT use case. On the right-hand side of the slide, you see a collection of modules, and modules is essentially what this talk is mostly all about, because hence the name multi-model. The idea behind modules is that you can extend a native Redis database server with an extended functionality that you simply load into the server when you start it up. The idea behind modules is to bridge this gap between the native data structures that Redis supports and more application-specific ones. Like, for example, graph databases are typically somewhat different from the Redis native data structures. If you load the graph module into Redis when you start the server up, that gives you an OpenCipher compliant graph database, similar to Neo4j, similar to Tiger Graph, with one important difference. The graphs are being kept in main memory, meaning that you have all the performance at your disposal that you need for fast processing of graphs. Similar things go for time series. The functionality of time series is quite comparable to something called Influx, a very popular time series database also found in the open source realm. Other modules include Redis Search, our answer to full text searching and indexing in main memory, and JSON, also known as the Redis JSON module, is comparable to a document-oriented database like MongoDB or even Couchbase. And before I forget, of course, both Redis natively and, of course, the modules do offer something called probabilistic data structures. Probabilistic data structures have an important trait. They are very memory efficient, but they are not, what's the word I'm looking for, absolute in their return value in terms of their result. For example, hyperlog gives you the cardinality of a set without having the necessity to store the complete set in main memory. The idea is essentially not to store the set itself in main memory, but rather to store hashes of the set items in main memory, giving it very compact representation. The only drawback, of course, if you have a hash collision, the two items will be counted as one, and hence the probability of the result being accurate is less than 1. Redis.io, which is the main website. At the very bottom, and I want to keep this really short, is a commercial offering based on, essentially, it's Redis with full support comparable to Kafka from Confluent in that case, or Red Hat Enterprise Linux from Red Hat. In addition to the open source, the supported open source code base, you get some enterprise features that are not available in the open source code base, like high availability, transparent high availability, I must say, because of course you can cluster the open source code base, and with Sentinels you can also basically ensure high availability. And other things typically found in enterprises basically cover, for example, security aspects. But enough about this. Let's take a look at how actually Redis is used on the edge as in typical IoT computing. So the idea is to combine Redis open source with streams and modules depending on a particular use case. So you can slot in time series, you can slot in graph. AI is essentially a combination of PyTorch, TensorFlow, and Redis. The idea behind artificial intelligence, hence the name of the module, is to give these backpropagation networks a very performant infrastructure. Because typically what you would see when you deploy TensorFlow or PyTorch, say in an ordinary environment, all the data would have been what would have to be loaded from disk, which makes it very expensive performance-wise to process that data then. And I didn't touch on that with the earlier slide. Gears is actually a very new module or very new addition to the ecosystem. Gears allows you to combine the functionality of different modules, but also provides an infrastructure for the execution of modules like filtering, mapping, and so forth. And the ability, and this is the first in the NoSQL space, you can actually ship your Python code to the server for the execution in the server context. That makes Redis the first database that is able to do so. Other programming languages are planned, including Rust, Java, and so forth. Um, the footprint, as it should be the case on the edge, is quite small. I came across Redis about 2 years into its existence. I was then looking for a performant PHP opcode cache that I was running, or that I had to run at the time, on an ARM5 architecture. This ARM5 architecture is a typical 32-bit die, and the platform that I had in mind, and I still run this platform today, by the way, is a single core, 512 megabytes of RAM, both for the OS and the whole stack running on that machine. And that gives you some impression. And that machine actually powers not only a Redis server, but a couple of Nginx instances working as reverse proxies, in addition to 4 Nextcloud instances, all running in 512 megabytes on the single core. That gives you some impression on how low the resource requirements of Redis are. Needless to say, because the code base is deployable on platforms like OS X, you can even run it. Actually, some people have run it, have built it on Windows. You can do this. Sigwin is supported. WSL, of course, because it gives you native Linux user land, is of course supported out of the box. So one of the traits of the code base that it's that is highly portable, because all it requires essentially is a post-compliant operating system base, and of course a C compiler. Needless to say, on the edge, you don't need only a very small footprint. You also need high performance, because as we all know, or as anybody knows who has dealt with IoT use cases, data on the edge tends to come in hard and fast. And depending on the number of sensors you have attached to your edge solution, this can reach up to the megabytes or gigabytes, depending on your particular use case. So you don't have an awful lot of time to process the incoming data. So hence the idea to put Redis not also in the backend, I'm going to cover this in a minute, but actually right on the edge, where it can collect data coming in from sensors and other data sources, and can process it very, very kind of in a very short amount of time, because as I said, the focus of Redis is actually on in-memory processing. And of course, the idea is, should native Redis be not sufficient on the edge, simply load your module of choice, and then you have the capability to process graphs, to process time series. Needless to say, that would be the primary use case that comes to mind, as an attached timestamps to incoming sensor data, so that you know when a sensor has delivered a certain piece of data. It all comes basically with the module. So this is the overall idea of having quite a very flexible tech stack right on the edge that is capable to process a significant amount of data coming in. Hybrid deployment. This is actually not just a theoretical slide. I'm going to go through the technical use case in a minute, but let's take a look at how this is done. You have Redis sitting on the edge, that is depicted on the left-hand side of the slide, collecting data from various sources like cars, like machinery, robots, and so forth. This is then amended essentially through modules also running on the edge. And for the more for the more powerful processing, each and every data that is processed already on the edge can be then forwarded to a cloud-based environment where also Redis is running for the already kind of pre-processed data. So you can do your aggregation, you can do your averaging, you can do an awful lot of processing already on the edge because you have a Redis instance supported by modules running natively on this. And this is not just bold theory. There are quite a few companies out there who do it like that. For example, unfortunately, I cannot name the name, but there's a large Swiss company in the area of logistics. They have little vans, they have little buses driving around the country, delivering goods, moving people from A to B. So each and every van has a couple of computers on that van, and one of these computers actually runs CentOS with a Redis instance, and this Redis instance is in charge of ticketing when people actually want to be taken from place A to place B, but also is in charge of uh, managing the packets, the items that are collected by these vehicles, also making sure that they're being tracked. And each and every one of these computers actually has a built-in SIM card, as in has a 3 or 4G mobile modem, meaning that this is actually the case that is depicted on this slide. So a good chunk of the processing is already done on the edge, is already done on the buses, on the vehicles, and then they can forward that data, pre-processed, I might add, back to the cloud that is running in a couple of data centers of this logistics provider. When you walk into this logistics provider, it's actually quite impressive because they can show, they're going to show you a dashboard where at each point in time they can actually tell you where a vehicle is because of the geolocation that is built into this vehicle. But in addition to this, they can also tell you what the exact number of passengers in this vehicle, and also the exact number of parcels or other items that are on this vehicle and where they come from and where they go to. And needless to say, all this in real time, because this is the beauty about it, because they want to know what's going on in Switzerland. At any point in time, they have the exact picture of what's happening. Needless to say, should a van break down, they immediately know this. As a matter of fact, the next stage, if I understood this correctly, was actually um, checking our preventive maintenance in terms of hooking up the Redis instance to the motor management component of the vehicle in order to see where there is a potential for a failure, engine breakdown, brakes going low on service and so forth, so that they don't have to wait until the bus breaks down, but rather can do it preventively in terms of making sure that if anything happens between the ordinary maintenance cycles, they can actually take action before it even happens. Quite sophisticated. And given the fact that there are quite a few thousand vehicles out there running around the country, moving goods and people, you can probably imagine what this means in terms of processing on the edge and also processing actually in the cloud then. Okay, moving on. Before I go into the demo, what I'm going to do now, I'm going to show you Redis Graph as a module case study. Redis Graph, I already touched upon this, is an OpenCipher compatible GraphDB extension for Redis. The idea is to adhere to industry standards, given the fact that Cypher, originally developed by Neo4j, is now with the definition of OpenCipher, industry standard. This is a Redis Labs decided, because we developed Redis Graph as a module, which is of course open source, by the way, as all our modules are. We decided to make this OpenCipher compliant to make sure that we meet this industry standard. In contrast to other graph DBs, the graphs are stored quite efficiently in so-called sparse matrices. The idea is you have a matrix that only has a 1 where there are 2 nodes connected via an edge. So the idea is to represent the 2 axes of a matrix for the nodes, and then where nodes are interconnected by an edge in a graph, you actually have a 1 in the matrix, and all the other positions where there are no connections, as an edges between nodes, these are zeros, or represented by zeros in the matrix. And there's a very efficient way. I won't go through the mathematical details, but these sparse matrices can be stored quite efficiently. And this is actually done in something called Graph Blast, which is a library for the efficient storage and processing of sparse matrices that actually is used internally in Redis Graph. And of course, this is also an open source component. The results are quite impressive. Preliminary tests that we have run over the last 2 years indicate that we can outperform an industry leader by 50 times. This is quite a lot, especially if you are looking at processing of graph data in real time. And of course, alongside other modules, the client ecosystem is quite comprehensive. So you have clients available for compiler-based languages like Rust, Golang, and Java, but also, needless to say, other programming languages are covered as well, like Python, JavaScript, Ruby, PHP, just to name a few. Okay, on with the demo time. So let's get our hands dirty and let's show you some code. First of all, I'm going to start Redis. So this is how you start Redis. So you just invoke a server and you just give it a configuration file. It starts up the server. And as you can see here, I'm loading quite a few modules when I start the server. I'm loading Graph, I'm loading Time Series, and I'm loading Redis Search. So now I have a graph database at my disposal. So let's take a look at the small demo implementation here. I've chosen Python to do a little bit of show and tell here. So the idea is to have a small graph that contains people, countries that these people have visited, and the purpose of that trip, whether it was for business or for pleasure. So let's take a look at how it's done. I won't go through this. I'll go through this very kind of quickly. Needless to say, if there are questions on this code, feel free to reach out to me as part of the Q&A section, or in this on the Zoom conference afterwards. So after deleting a previously existing graph with the name of travel, I actually create one. I give it an initial node. So the idea is to just create a node. I label person. The properties I can attach properties to edges that connect nodes, and of course nodes itself. These properties, consider it to be metadata that is attached to an item. In this case, it's a name, which is John Doe, an age, 33. He's of course a male, and status is single. So I simply add then this node to the graph. I do a similar thing for a country that John Doe has visited. And then I connect these 2 nodes with something called an edge. So I'm going to do the same for Pearl White, who visited Australia, but now not with the purpose of pleasure, but rather for a business trip. This is basically this edge definition. Once I've created the graph, I simply say Redis_graph commit, and then the graph is committed to the server instance. Now, if I want to query this graph, this is really straightforward. So let's say I want to query the graph for the purposes of the trips. So the idea is to construct a query, and this is pure OpenCipher that you actually are seeing in line 45 and 46. So this query essentially says, give me all the persons that visited a specific country for the purpose I specify. So all I have to do is actually, and the I is an iterator, so it just goes through a list, pleasure and business, and simply gives me then back the corresponding nodes and from the graph. So all I do is actually I ship off the query to the server that gives me back a result set, which I simply print out here in this method in this print result method. So the idea is essentially to extract the data from the result set, and the result set is a list of results. So I can use simply an iterator to go through this. So result set is a collection of record, and a record contains the person's name, age, gender, status, as in the stuff basically in the properties. That's how it works. And then finally, the print statement actually just does some printing. So this is not exactly rocket science, and this is that gives you some impression how easy it is actually to use OpenCipher in Redis Graph. So let's give that a whirl. Redis is already running, of course. So all I have to do now is actually I have to execute it, and as expected, it gives me back John Doe visited Japan for the purpose of a vacation, and Pearl White visited Australia because she had business to do there. This is how it's done. And as I said, it's quite straightforward, and this is just a very simple demo showing you how it's actually done. Okay. Last slide before we go into the questions. Conclusion, Redis and its model ecosystem give you a very flexible approach to storing your data, because not only do you have native Redis at your disposal, you also have the whole model ecosystem with that rich set of capabilities depending on your particular use case, whether it's time series, whether it's graph, whether it's real-time search, you name it, modules out there fulfilling that requirement. And of course, you can deploy edit Redis right from the edge, right back to your cloud I'm almost tempted to say back office environment, but it's much more than that. The backplane, essentially, where you have possibly terabytes of data that you're processing, but pre-processed already on the edge, by the Redis instances running on the edge, as just explained. Because of the compactness of Redis, because of the very low footprint, you can use Redis on the edge wherever you want. I've actually seen people squeezing Redis into microcontrollers, and I think there's also a project out there that tries to port Redis to field programmable gate arrays, which is quite a what's the word I'm looking for? A feat, so to speak, because these are machines that are very, I wouldn't say powerful, but you get the idea. They don't do an awful lot, but then they are very cheap and they are very compact. So this is the overall idea. So the idea is actually you have a computing infrastructure, you have a little bit of hardware. Chances are Redis is going to run on it, and of course you have quite a comprehensive ecosystem. The module SDK is publicly available, is specified. It can talk to any programming language that supports C bindings, and of course that includes Rust. As a matter of fact, Redis JSON 2, as in the second version of Redis, is actually re-implemented in Rust. Redis JSON 1 was implemented in C, but because Redis Labs or portions of R&D in Redis Labs are moving to Rust more and more, Redis Labs decided to re-implement the version 2 in Rust rather than C. There's also a FOSDEM talk available. I gave a presentation at this year's Free and Open Source Developers European meeting on the subject that has some interesting performance figures in terms of what you pay when you go from C to Rust. Feel free to be sure to check it out if that's of interest for you. You'll find actually the link on the FOSDEM website, including the video. And of course, last but not least, you have a very rich client-side environment at your disposal, ranging from multiple clients per programming languages right up to the module client-side implementations and the functionality that is available on top of these module implementations. And with that, I would like to thank you for your attention. If there are any questions on Slido, now is the time to ask me. And we already have a question, yes. And the question is, can Redis save 100 terabyte of data? As a matter of fact, yes, it can. Assuming that you have the hardware at your disposal. There are quite a few customers mostly using enterprise, I might add, because this is where enterprise really shines. Because with that sort of data set size, you're looking at a quite significant number of open source instances that you would have to use if you are not running this on a very, very large machine. Yes, 100 terabyte or even larger data sets is not unheard of. It's not the common use case, but it can be done, assuming that you either cluster the data or have a very few powerful servers at your disposal with the corresponding footprint. How expensive is Redis? Next question. As a matter of fact, it's free. You just go to GitHub .io/anti-rest/redis, or I think, sorry, there's also a newer, I think that's a forward these days. The actual URL is github.io/redis/redis. It's a 3-clause BSD code base, so you simply clone the code base. And all you need, as I said, is a PostGIS compliant operating system. So OS X, any BSD will do, any Linux, of course. More often than not, Redis would be part of the standard operating system packages you would get from your distribution. So all the major ones like Ubuntu, like CentOS, like RHEL, like Arch, even Homebrew on OS X has Redis available as a package. So just basically either clone the code base from GitHub or simply install it through your operating system package management. Next question. Can Redis work in some kind of masterless architecture like, for example, Cassandra does? I'm not too sure what you mean by masterless. Or multi-master is the high available way here. Sorry, multi-master. So as a matter of fact, there is something called Sentinel out here. Sentinel, if you check the documentation on redis.io, you will find the idea is that you actually have master and slave instances, as they were called previously, because I think these days in terms of political correctness, the favored terms would be main instance and replica. And the sentinels are actually in charge of controlling high availability here. So if I understand this correctly, Cassandra doesn't need this, but Redis actually does support main shards. The idea is that sentinels, hence the name, continuously monitor any main shards, any replicas, and make sure that should a main shard fail, a replica can take over. This is the overall idea. So the next question, is Redis faster than MySQL? Yes, it is. There have been done numerous benchmarks just use your favorite search engine. Just search for benchmark MySQL Redis, and off you go. As I said, this has been documented quite a lot. So just reach out to Google and friends. And I think with that, I've reached 45 minutes, if I'm not completely mistaken. To reach out to me and be any questions asked. So I will be there in about 2 minutes time once I have concluded this presentation. Um, Very last question before I go. Does Redis handle concurrency? Very important one. The server is single threaded. Only some sort of persistence is done in a background thread. But needless to say, as with almost every other aspect, you can control this server side. So the idea is to server with a very complex multi-threaded approach, but rather give you ultimate performance. This is the reason for a single thread. The advantages, this is at least my experience after using Redis for 8 years, far outweigh the disadvantages. And with that, I would like to conclude my talk. Thank you for your interest. Thank you for your time, and goodbye.